Separation of mixtures. By the end of this video, you will be able to describe the different methods of separating mixtures. If I can get it to go to the right one. Here we go. Alright. First method is filtration. Filtration is a process that separates an insoluble solid from a liquid. So you have to recall what it means for something to be insoluble. Say we have sand and water. Sand is not soluble in water. It would not dissolve. So if we were to put that through a filter, the residue is what gets left behind. So the sand is the residue. It's going to get stuck in the filter. It's not going to pass through. The water, however, passes through and goes to the bottom of the flask, and that's called the filtrate. Okay, the filtrate is what passes through the filter. The residue is what does not pass through the filter. Now that's a simple process. Distillation is slightly more complex, but it's the same principle. We're separating a mixture. So distillation is a process that separates the solute from a solvent excuse me, by taking advantage of a difference in boiling point. So say we had salt dissolved in water. So that's my salt water solution. We add a little bit of red to it to make it easier to see. The salt, even if you were to look at this solution under a microscope, you will not be able to see the individual particles. It's a solution, it's a homogeneous mixture. So if you pour it through a filter, all of it's going to pass through. You need to separate this mixture by distillation. So this is the distillation process. This is the apparatus. This is what it looks like. And the distillate, pure water, is in the receiving flask. So this right here, this is the pure water. The salt is going to be left behind in the distilling flask. This is where everything starts off at. So the first step in the distillation process, the first step is to boil the mixture. And when we do that, water, which is the solvent, water boils at 100 degrees Celsius. Salt, which is the solute, it boils at a much higher temperature. So the salt is not going to boil. See, distillation, the idea is that it takes advantage of a difference in boiling point. As soon as this hits 100 degrees, the water is going to leave. The salt is going to get left behind. So as water vapor travels up, the water turns from a liquid to a gas and leaves the flask. Because remember, water boiling at 100 degrees Celsius, that just means it's turning from a liquid to a gas, water vapor. The salt does not change phases. The salt remains a solid, and so it is left behind. Now the thermometer measures the temperature of the water vapor, and it's 100 degrees Celsius because that's the temperature where the water is going to evaporate. The next step, you have a bunch of 100-degree water vapor coming through this apparatus. It's going to go inside of this tube. So what you have to do is we have to cool that vapor. Water vapor flows into the condenser, a device with a narrow inner tube surrounded by an outer tube. This is the inner tube, this piece right here, surrounded by that outer tube. And the water vapor is going to flow into the inner tube, where it's surrounded by the cold water in the outer tube. This arrow is actually supposed to be in the inner tube because the water is flowing inside of this inner tube. So let's just pretend that this arrow is actually pointing in here. That's where the water vapor is flowing through. The cold water outside of the tube, so that's around here, cools down the water vapor inside of the tube to below 100 degrees Celsius. So the water vapor is going through here, and we have cold water being pumped in the outside, and it's going to cool down the vapor inside of the inner tube. And when that happens, you go to step 3. You collect a pure liquid. When the water vapor cools below 100 degrees Celsius, it's going to turn back into a liquid, which then drips down into the receiving flask. The substance that has been distilled, in this case water, is called a distillate. So this right here is a distillate. That is what has been separated from the mixture. And that is the process. We boiled it, water vapor leaves, and it evaporates at 100 degrees. It comes through here into the condenser, into this narrow white tube, where it's cooled off by water being pumped in around it. And as it cools, it condenses back down to a liquid, and you have the distillate, pure water, in here, and the salt is left behind back there. Another method of separating mixtures is called chromatography. Chromatography is a process that separates a mixture based on how fast molecules move. So this is how it works. First, what you do is, well, let me play this. First, you place the water in a solvent, and then it's going to rise up. You place a paper in a solvent, it's going to rise up. And if you look, the green marker traveled faster than the yellow marker. Let me repeat that. You have a slip of paper, we put it in a solvent, and the solvent is going to travel up the strip of paper. We have two dots of ink. The green ink traveled a lot faster than the yellow ink. And so that's the basis for chromatography, separating mixtures based on that. The two dots from different colored inks are drawn on a white strip of paper. This is called the stationary phase. So the paper is called the stationary phase. The bottom tip of the paper is placed in a solvent, for example water, and the solvent travels up the paper. When it reaches the ink, it's going to carry the ink molecules with it. So that's called the mobile phase. Let's look at that again. And watch as the solvent travels up, the water travels up, that's the mobile phase. The green ink molecules traveled faster than the yellow ink molecules, and that's why it got farther. Now here, this is an example, a real life example. The initial dot of black ink is placed on that strip of paper. Blue ink molecules, they travel faster through the mobile phase than red ink. Sorry, this got jumbled up. But the blue ink travels faster. That's why it got farther. It's the same reason why the green ink over here got farther, because it travels faster. The black ink is thus separated into red ink and blue ink, and the blue ink travels faster than the red ink, and that's how it was able to be separated. So it appears that the black ink is a mixture of red and blue inks, as we can see from the chromatography paper.